All right, today we're going to pull back the curtain on the real secret sauce that makes search engines feel like they can practically read your mind. You know that feeling, right? You type in just a few words, and somehow it just gets it. It knows exactly what you're looking for. Well, that's not magic. It's actually a really clever engineering concept that learns from everything we do online, all together. So this core idea? It's called signals boosting. And really, you can just think of it like a giant popularity contest. Every time you click on a result or add something to a cart or actually buy it, you're casting a vote. You're telling the search engine, hey, this is a good one.
Okay, so we're counting votes. Simple enough, right? Well, not exactly. Before we can do that accurately, we have to deal with a huge problem. Our searches are just a total mess.
Just think about how people might search for an iPad. Someone might type iPad with a capital P, someone else all lowercase. Another person might type iPad with a space, or maybe iPads with an S at the end. To a machine, every single one of those is a totally different search. It splits the vote, you see, and that really weakens the signal.
But check this out. After a super simple cleanup process called normalization, which is basically just making everything lowercase, look what happens. All those scattered signals for iPad and its variations, they all get combined, and boom. The top query jumps from just over 1,000 clicks to almost 3,000. Now that is a much stronger and more meaningful signal.
And that's really the whole point, isn't it? This one little cleanup step is the foundation for everything else. It makes our popularity contest way more accurate, because it makes sure every single vote for the same idea actually gets counted together.
All right, so now we've got a clean signal. Let's talk about the next upgrade. Because, let's be honest, anytime you build a system based on popularity, you're going to get people who try to game it for their own benefit.
So, let me tell you a little story. Imagine a user, we'll call him our spammer, and he really hates the new Star Wars stuff. I mean, he feels so strongly about it that he wants to make sure anyone who searches for Star Wars sees a trash can as the #1 result.
He comes up with this simple but kinda evil little plan. Step 1. Search for Star Wars. Step 2. Ignore all the actual movies and instead click on a Star Wars-themed trash can. And step 3. Repeat this 5,000 times. He's trying to flood the system with fake votes.
And you know what? It works. His spammy little campaign is a total success. That trash can with 5,000 artificial votes just rockets to the top of the search results. The system has been completely gamed.
So, how do you fix this so-called Star Wars problem? Well, the solution is actually beautiful in its simplicity. You just change the rules of the election. You tell the system, hey, from now on, only count one vote per user for the same search and the same product. That's it.
And just look at the power of that one simple rule. Before the spam, the trash can had 0 boost. After the spammer's attack, it has a boost of 5,000. But once we apply our cleanup logic, poof, all 5,000 of those fake clicks get squashed down to just one, a single insignificant vote. Problem solved, villain defeated.
Okay, so our system is clean and it's secure from spammers. Now, let's make it smarter. Because the key insight here is that not all votes are created equal. Some actions we take mean a whole lot more than others. Think about it. A simple click, that's a pretty weak signal, you know? You could just be window shopping, browsing around. But a purchase, whoa, that is a massive signal. You actually pulled out your wallet and spent real money. That tells the search engine you were very serious.
So we can build this right into the model by giving different actions different weights. A click gets, say, 1 point. An add to cart might get 10 points. And a purchase, that's worth a whopping 25 points. We can even go negative. If you remove an item from your cart, that's a negative signal. And if you return something, that's a huge one, like minus 100 points.
And here's another cool trick, making the model time sensitive. I mean, what was popular 3 months ago might not be what's hot today, right? So we can use something called a half-life. A signal is worth the most right now, but its power fades over time. This keeps the search results fresh and relevant to what's happening now.
All right, we're at the final step. The model is designed, it's smart, it's secure, but now the engineers who build this stuff face a classic dilemma, a fundamental trade-off. What do you prioritize? Flexibility or raw speed?
So you've got 2 main paths you can go down. Path 1 is called query time boosting. It's super flexible. Engineers can tweak things and experiment easily. The catch? It's slower. Path 2 is index time boosting. This one is blazing fast and super scalable. The downside? It's rigid. If you want to change anything, you pretty much have to rebuild the entire system from scratch.
So, which one do you choose? Well, it really depends on what you're building. If you're a news site covering breaking stories, you need to react to trends in real time. You absolutely need that flexibility. But if you're a giant e-commerce store with millions of products, that raw speed and stability might be way more important to you.
So there you have it. Behind every simple search bar is this incredibly sophisticated system constantly collecting, cleaning, and weighing everything we do. The next time you search for something, just remember, you're not just finding an answer, you're teaching the machine. Your clicks are the secret sauce.